Oh, welcome. Let's get started. So let me share my screen. Let me also check that everything is perfect on other side. Yes. I hope my screen is visible now. Okay. And yes, let's get started once again. So, good morning, everyone, and welcome back. It's good to see so many of you returning. And if this is your first session with us, you are very welcome and you will not be lost. Let me take 30 seconds to remind us where we finished last time, because today follows on directly from it. In our previous session, we spent our time in OneLake. We looked at how to discover data that already exists across the organization and how to connect to it. And we spent a good part of the session in one catalog, browsing what was there, searching for items, looking at what the catalog can tell us about the data before we ever open it. So we finished last time knowing how to find data. Today we ask the obvious next question. Once we have found it, where do we put it and what do we put it in? That container is the lakehouse and it's what the whole of today is about. So here is how we'll spend roughly an hour, maybe less than an hour. We'll start with the problem because the lakehouse is an answer to a very specific frustration. And it makes far more sense once we have felt that frustration ourselves. Then we will look inside one and take it apart. We will look at how data gets in, how we query it, and how Power BI reads it. And I will show you pieces of product as we go so that nothing we discuss stays abstract. Please use the chat throughout on YouTube. The question asked in the moment is word 3 asked at the end. Quick recap so that today sits on top of last session rather than beside it. Last time, everything we did happened inside OneLake, and the key idea there was that OneLake is a single storage layer for the entire tenant. OneLake, not one per team and one per project. Every Fabric workload reads and writes into it. We spent most of our time in one catalog, and the thing I hoped you took away was the habit it encourages. Before you build anything, go and look at what is already there. We browsed, we searched, and we inspected items, and we could tell a great deal about the dataset from the catalog before even opening it. And then we connected to that data, not copied it, not rebuilt it, connected to it. So last session answered, how do I find data? Today answers the question that immediately follows. Once I have found it, or once I have my own data to bring in, what do I put it in? What is the thing that holds it, structures it, and lets other people query it? That thing is a Lakehouse. So here is the shape of the hour. We open with the problem. I want to spend real time here because if you only learn the definition of a lakehouse, you will forget it by Friday. If you understand the frustration it removes, you will never forget it. Then the definition itself and where a lakehouse actually lives in fabric. Then anatomy. And section 3 is the important one. There are two zones inside the lakehouse, tables and files. And almost every design decision you will make comes back to choosing between them. Section 4 goes underneath the tables to Delta Lake, which is what makes the whole thing work. Section 5 is how data gets in. There are 5 different views, and choosing well between them is a genuine skill. And section 6 is how we get value back out. SQL, Spark, and Power BI. One note on format. Roughly half of today is slides, and half is me in the product. Every time we finish an idea, I will show you that idea running in Fabric. Actually, I will do it in our next, upcoming session, like I'm going to demonstrate lab. You do not need to follow along, but if you have a workspace with capacity, you are very welcome to during lab session, next session. Let's start with the problem. And I'm going to describe a situation rather than a definition because I suspect a good number of you are living in it. For years, for years, this was the choice. On the left, a data lake. It gives you flexibility and scale. Store anything in any format cheaply and worry about structure later. That last part is genuinely valuable. It means you can capture data before you know what you will do with it. What a lake does not give you is a transaction. There is no way to safely update a row. There is no guarantee that somebody reading sees a consistent picture while somebody else writing. And analytical performance is whatever you manage to engineer yourself. On the right, a data warehouse, and it's almost the exact mirror image. Transaction schema enforcement, fast queries, a security model that has been refined for 30 years. So, and in exchange, it wants your data structured up front. In formats, it approves of, and it gets expensive as you grow. Look at the two butt lines, these lines. Each system is weak precisely where the other is strong, which is why so many organizations ended up running both. So you do what almost everyone did. You keep the warehouse for the structured data it handles well. You stand up a lake beside it for everything awkward, and you run pipelines between them. And that works. But look at what it costs you, because these four not are not theoretical. Every one of them is somebody's Tuesday. First, duplicate data. Anything that is needed in both places exists twice. And the moment there are two copies, they begin to drift. Then somebody asks why the sales number in the report does not match the sales number in the lake, and you lose a day. Second, permission. Two security models maintained separately, slowly disagreeing with each other. Someone leaves the company and is removed from one of them. Third, governance. The question your auditor asks, where did this come from? Who touched it? What is sensitive? Has to be answered twice into different tools. And fourth, that pipeline in the middle, somebody owns it. It has no business value of its own. It exists purely because your two systems cannot talk to each other. And it breaks at 3 in the morning. The Lakehouse is an attempt to delete this entire slide. So let us define it properly, and then look at where it lives in Fabric. Here is the definition, and the name is doing something clever. So it's worth saying out loud. It's the lake part of data lake and the house part of data warehouse. The flexible, scalable storage of one and the ability to query and analyze of the other. Mechanically, what that means is this. Your data still sits in open file formats in a data lake. That has not changed, and that's the point. But database-like capabilities are brought to those files rather than the files being loaded into a database. Transactions, schema enforcement, agent updates fly to the files where they lie. And note the consequence in the box at the bottom. You are no longer choosing between keeping the raw file and having a governed tape. Yes. So you keep the raw file for compliance or reprocessing and the structure table for analytics in the same lakehouse under one set of permissions. The same we saw on the last slide simply is not there. Now, where does a lakehouse actually live? In Microsoft Fabric, the storage layer is OneLake, and you already know it from last session. One tenant, one lake. Every lakehouse you create, every warehouse, every item that holds data, it all lands in one lake. You can see that on the top. Three different items owned by three different teams, doing three different jobs. Our one storage layer underneath all of them. And this matters more than it sounds. So let me be concrete. Because everything is in one lake, data written by one workload is immediately available to another. When Spark writes a table, Power BI can read those exact files. There is no export. There is no copy. There is no overnight sync. And there is no awkward conversation about why two systems disagree. This is the agricultural bet Fabric has made. It's also the reason that everything we look at for the rest of the session hangs together. The query engines, the shortcuts, direct link at the end, all of it follows from there being one just lake. A lakehouse gives you two compute engines over that storage. Apache Spark for code-based processing at scale, PySpark, Spark SQL, Scala, if you must. And SQL for familiar querying, which is where most analysts will live. I want to be precise about the picture on the right, because this is the part that people miss here. These are not two copies of the data with two engines on top. There is one copy, one set of data files in one lake, two different ways of reaching them. The practical effect is in the box on the left. A data engineer writing PySpark and an analyst writing T-SQL are working on the same table at the same time with no handoff between them and no export in the middle. The engineer finishes a load and the analyst sees it. That's the whole idea. And because there is no duplication, there is no nothing to sync and nothing to drift apart. So you choose your engine per task, not per project. We will look at how to make that choice in the last section. Now let us open one up. This section contains the single most important idea in the session. So if your attention wandered anywhere, bring it back here. This is the slide I would photograph if I were you. Open any lakehouse in Fabric and the Explorer pane shows you two nodes, tables and files, and they're deliberately, fundamentally just different. Files on the right is a managed storage. It's functionally a folder. You can put anything in it. CSV, JSON, Parquet, images, PDFs, whatever you have. Nothing is validated. No schema is enforced. Fabric is entirely relaxed about what you drop here and there. And the price of that flexibility as the bottom of the cart. You cannot query it with SQL. It's a file. Then SQL Analytics endpoint cannot see it. Tables on the left is managed storage. And everything in it is a delta lake table enforced schema. Write data that does not match and the write is rejected rather than quietly corrupting your table. Acid transactions. Queryable with SQL, readable by Power BI, and Fabric optimizes and maintains these for you in the background. So what's files actually for? Two things. It's a landing zone. Raw data arrives there and gets processed onwards. And it's your archive. You keep the originals for just origins for compliance. And so you can reprocess when you discover your transformation logic had a bug in it, which it will. Read the line at the bottom. Raw data lands on the right, and a very large part of the data engineering job is moving it to the left. Almost every design decision you make in a lakehouse comes back to this one distinction. One more thing about the table side before we go underneath it. When you create a lakehouse, schemas are enabled by default, and a schema called DBO is created automatically. If you have come from SQL Server, that name will be familiar, and it means exactly what you would expect. What schemas by you is organization. Two tables do not need organizing. 200 do. So you group them by business domain, sales, marketing, HR, as you can see in the tree on the right. And they unlock two things beyond tidiness. So first, schema level permissions. You can grant the marketing team access to the marketing schema rather than granting table by table and forgetting one. Second, let's swing at the bottom. The four-part namespace, workspace, lakehouse, schema table. That's what lets you write a single query that joins data living in two different lakehouses in two different workspaces. Without moving any of it, we will come back to that at the end, actually tomorrow. When you create a lakehouse, there is a checkbox for this. And actually, we don't see it here, but while you are creating a lakehouse, you can see there. And it's ticked by default. Leave it ticked. Untick it, and every code simple you find, including mine, will fail with a table not found error. Lakehouse gives you two working modes, and there's a selector in the top corner of the product that switches between them. The Lakehouse Explorer is the management mode. This is where you add tables, upload files, create folders, change things, read and write. It's also where you can add reference lakehouses. So you can browse tables across several lakehouses side by side. Useful when you are working across domains. The SQL Analytics endpoint is the query mode. It's created automatically with every lakehouse. You do not provision it and there is nothing to configure. You get to SQL over your delta tables. You can create views and functions. You can apply SQL security. And the crucial word is read-only. You cannot modify the underlying data through the endpoint. I'm flagging that now in bold because it's the single most common surprise for people arriving from a SQL Server background. You will write an insert, it will fail, and you will assume something is broken. Nothing is broken. If you want to change data, you are in the wrong mode. Go back to the Explorer or use a notebook. I have said Delta Lake table several times now. Let's open that up because it's the engine room of the whole thing. Delta table or Delta Lake is an open source storage layer. And I want to stress open source because people assume this is a fabric format. It's not. When you create a table in a lake house, what's physically written into one lake is two things, and you can see both on the right. First, set of Parquet data files. Parquet is a standard open columnar format, and it has been around for years, nothing exotic. Second, and this is the whole trick, transaction log. That's the delta log folder. Every change, every made to the table is just recorded. There is a numbered version. Version 0 is the original write. Version 1 is whatever you did next. That's it. So that's the entire innovation. Files plus a log of what happened to them. And because the format is open, other engines that speak Delta can read these files directly. There is no export step to leave and no login to accept. Your data remains in a very literal sense yours. Now, from that one small addition, for quite large capabilities fall out. For capabilities all falling out of that log. See transactions. Multiple people reading and writing the same table at once without corrupting it or seeing half finished results. Write either full happens or it does not happen. This is the thing a plain data lake cannot do. And it's exactly why just put Parquet files in a folder stops working the moment you have more than one job. Schema enforcement. The table knows what shape it expects. Write a string into an integer column and delta rejects the write rather than accepting it and leaving you to discover the problem 3 months later in a report that the director is reading. Time travel. Because every change is a numbered version, you can query the table as it existed at an earlier version. We will spend a slide on this next. And efficient updates and deletes. Update, delete, and merge against data in a lake. That sounds remarkable until you remember that in a plain data lake. Updating one row means rewriting files by hand and hoping nothing else touched them in the meantime. Time travel deserves its own slide because it sounds like a party trick until the day it's not. The picture on the right is a table's life. Version 0, the initial load. Version 1, a price update. Version 2, last night's append. And the point is that all three are still queryable. The past has not been overwritten, it has been recorded. The syntax is as simple as it looks. Version as of 0, and you are reading the table as it existed at its first write. Three situations where this earns its keep. A pipeline runs overnight and corrupts a table. You do not restore from backup and lose the morning you released yesterday's version. Someone asks what a report would have shown at month end. 3 weeks after month end, you query the table as of that point. An auditor asks what changed and when. The transaction log is the answer, and you did not have to build an audit system to have it. One honest caveat so you are not surprised in production. History is not infinite. Delta retains old versions according to a retention setting, and the maintenance operations eventually remove files no longer needed by recent versions. So treat this as a recovery window, typically days, not as a permanent archive. An empty lakehouse is an expensive folder. Let's get data into it. So Fabric gives you 5 routes. And I want to walk all five because choosing well between them is a real skill, and the wrong choice creates work that lasts for years. One upload, drag uh, files from your machine into the Lakehouse Explorer. Exactly what it sounds like. Perfect for a demo or a sample dataset. Not a production strategy because a human being has to do it every time. Two, load to table. Take a file that's already in your lakehouse and turn it into a data table without writing any code. Supports CSV and Parquet and lets you append to or overwrite an existing table. This is the no-code path from files to tables, and I will show it to you in a moment. Actually, most probably in tomorrow upcoming session. Three, data flows Gen 2. Ingest and transform using Power Query. If you have built anything in Power BI or used get and transform in Excel, this is the same interface and the same muscle memory, strong choice for analysis. For notebooks, Apache Spark, the most powerful and flexible option, and the one that scales to genuinely complex transformation. It's also code, which means version control, code review, and testability. Things the visual tools make harder. Five, data factory pipelines. The copy data activity, pulling from external sources on a schedule with orchestration around it. This is your answer when data lives in an operational database or a SaaS application and has to arrive reliably every night. And the framing for choosing is in the box, not which is best. Ask who maintains it and how often it runs. Mixing several of these in one lakehouse is completely normal. Let's look at the second route in detail because it's the shortest path from raw file to queryable table, and it's genuinely satisfying. On the left, a CSV sitting in the files area. Under uh, staging folder, right now is inert. Nobody outside this lakehouse can query it. Power BI cannot see it. The SQL endpoint does not know it exists. In the middle, load to table. You select a file, choose load to table, name your table, and confirm. The dialog will ask about the header row and the separator. And if you are loading into an existing table, it will ask whether to append or override, which is how you would use the repeatedly rather than once. And if you want to be clear about what happens next, because it's a genuine conversation, not a registration. Fabric reads the CSV, infers the types, writes Parquet files, and creates the transaction log. It's building a real delta table. On the right, the result, dbo.cells, governed, queryable, and visible to the entire platform. That's the files to tables move from our anatomy slide in about 40 seconds with no code. One honest caveat, because load to table is seductive, it infers your types on a demo file, that is fine. On a file where a product code happens to look numeric this month and will not next month, inference will quietly make a decision you did not intend. For anything that runs more than once, define your schema explicitly in a notebook. Convenience now or predictability later. That's the actual just grade. Everything we have looked at so far involves data arriving in your lakehouse. Let me show you the alternative, which is often the better answer. A shortcut lets you use data that lives somewhere else without copying it. It creates a reference, and that reference appears in your lakehouse as an ordinary folder or table. In the picture, DBO regions uh, is not mine. It lives in ops underscore lakehouse, owned by another team. But it sits in my Explorer alongside my own tables, and in a query, I treat it identically. Read the line at the bottom because it's the argument for this feature. So every copy of a data set is liability. It costs storage. It goes stale. Someone has to main the pipeline that refreshes it. And when the copy and the original disagree, and one day you will lose an afternoon working out which of them is right. So shortcuts remove all of that, but not making the copy in the first place. The data has not moved. There is exactly one copy, still owned by the team that owns it. And when they updated it, I see the update. You can point a shortcut at another lakehouse in Fabric, at a different storage account, or at another cloud provider entirely. Two things worth knowing, and then one thing worth remembering. First, permissions are not bypassed. When you access data through a shortcut to another OneLake location, OneLake uses your identity to authorize the read. You need permission in the target location. So a shortcut is not a clever way around access control. It's a way around copying. If you cannot read the source directly, the shortcut will not help you. Second, you can shortcut an entire schema, not just one table at a time. A schema shortcut maps a whole folder or delta tables in another lakehouse or in Azure Data Lake Storage Gen 2, and every table in it appears in yours. That's how you would consume a whole business domain owned by another team without duplicating a single row. And the thing to remember, a shortcut is a reference, not a snapshot. If the source is deleted or your access to it is revoked, the shortcut breaks. There is no local copy to fall back on. That's a genuine trade, and it's worth being explicit about it. You are accepting a dependency on someone else's data in exchange for never holding a stale copy of it. Most of the time, that is the right trade. Occasionally, for something you must be able to reproduce years later, it's not. A short slide because the tools will be familiar by now. They are the same one we just made for ingestion. The reason they reappear is that ingestion and transformation are really separate steps in practice. You ingest raw data into files, then transform it and load it into tables, and the same tool usually does both halves. Notebooks are favored by data engineers who are comfortable in PySpark, Spark SQL, or Scala. They handle logic that is awkward or genuinely impossible in a visual toolbar, actually a tool. And being code, they give you version control, code review, which matters more than people expect once a pipeline is 3 years old. Data flows, Gen 2, use Power Query. So this with anyone who has built in Power BI or Excel. Same interface, no new language. The strongest fit is where an analyst owns the refresh rather than an engineering team. Pipelines give you a visual interface for orchestration, multiple activities, running in sequence or in parallel on a schedule. And note the italic line. You often use a pipeline to run the others. A pipeline that triggers a notebook at 2 in the morning is one of the most common patterns in Fabric. Copilot is worth a mention here too. In notebooks, it will generate transformation code from a plain description and explain Spark code you have inherited from someone who has left. Useful while you are learning the syntax, though I would still read what it produces before running it. We have data in, let's get value back out. There are two engines over the lakehouse and a reporting layer on top, and I want to be clear about when you reach for which. The first engine of, and actually, for many people, the one they will use most. The SQL Analytics endpoint is created automatically with every lakehouse. You did not provision it. There is nothing to configure, and it's already there waiting for you. What you get is T-SQL over your Delta tables. The query on the right is nothing exotic, joining sales to products and aggregating by category. If you know SQL, you already know how to use this. Three things people use it for: ad hoc queries, investigating something now, to answer a question now. BI connections, Power BI, Excel, or any SQL client. Connecting to explore before anyone builds anything. Any data validation, checking that a load actually produced what you expected, which is a habit worth forming. Two features worth calling out. You can create views here. Same idea as any SQL database. The query logic is stored under a name, and everyone downstream uses the name. That's how a merging calculation or exclude discontinued products rule gets defined once, instead of being re-implemented slightly differently in relevant reports. And the endpoint supports row level and column level security. So row level restricts which rows a user sees. A regional manager sees their region only. Column level restricts which columns. The analytics team sees the sales table, but not the cost column. Both are enforced when users query through SQL, which means you set it once rather than in every report. And remember, the constraint from earlier, read only, nothing here writes. The second engine, notebooks, give you a code-based environment over exactly the same data. And you have two languages available. Spark SQL, first one. At the top left is SQL syntax in a notebook cell. That double percentage SQL at the start is a magic command telling the notebook to treat the cell as SQL rather than Python. If you know SQL, there is no learning curve at all. PySpark, below it, is Python. You can run a SQL string with Spark SQL and get a data frame back, or use the data frame API with select, filter, group by, chain together, as in the example. And the first bullet on the right is the important one. Both approaches run against the same tables and produce identical results. So you are not choosing a technology. You are choosing which line of code is easier to read. SQL is clearer for set-based work, joins, aggregations, filters. PySpark wins when the logic is genuinely procedural, when you need a Python library, or when you are preparing data for a machine learning model. And you can mix them freely in a single notebook, a SQL cell followed by a Python cell, working on the same table. So when do you open a notebook rather than the SQL endpoint? Three cases in the green box. Exploratory analysis, where you want charts in line as you go. Complex transformations that are painful to express in SQL, and anything that writes, because as we said, the endpoint cannot. This is where those schemas we discussed earlier finally pay for themselves. The four-part namespace is workspace, lakehouse, schema table, schema actually, table, a fully qualified name. And what it means is that I can write a single query that reads from two lakehouses in two different workspaces and joins them. Look at the query, this one. Sales come from one workspace. Regions comes from another. From sales, joins, yes. So regions here comes from another, owned by a different team. One select, one result set, and not a single row of data has been moved or copied to make it happen. Think about what that replaces. In the world we described at the start of the session, joining across two systems meant a pipeline. Extract from one, land it in the other, schedule it, monitor it, and explain it to your auditor. Here it's a fully qualified name in a from clause. That's the OneLake promise made concrete. One copy of data, many engines, and the boundaries between workspaces stop being walls. They have one condition, and it's the right one. This is subject to your having permission in both places. Fabric is not handing your data you were not entitled to. It's removing the plumbing between data you were already entitled to. Last stop on the way out, Power BI is the consumption layer, where business users actually meet your data. There are two ways it connects. An analyst can query the SQL Analytics endpoint directly, which is what you do while you are still exploring and have not decided what to build. Or you build a semantic model over specific lakehouse tables, defining relationships, measures, and business logic. And that's what anything durable sits on. And then the interesting part on the right. Historically, you choose between two modes. Import copies data into the model, fast queries, but the data is only as fresh as your last refresh. Direct query always sees current data, but sends a query to the source every time, so it's slower. Direct Lake is the third option, and it's the default for Lakehouse semantic models. It reads directly from the Delta Parquet files in OneLake. No import, no copy, no scheduled refresh. You get performance close to import with data that is always current because there's no second copy to go stale. Okay, and look at the box on the left because this is where the whole session closes its loop. The reason Power BI can read those files directly is that they are sitting in the same OneLake that Spark wrote them to. Same files. That's why everything being in OneLake was worth the architectural bet. One honest note. Under certain conditions, a direct lake query can fall back to direct query behavior, which is slower. Worth knowing that exists before you promise anyone performance numbers. Once you have centralized data in a lakehouse, protecting it becomes the interesting problem. Fabric layers the controls, and you pick the level that matches the need. Workspace roles are the broad instrument at the top. For collaborators who need access to everything in the workspace, team members who work together on the whole thing. Item level sharing is narrower. Grant read only access to one lakehouse for a specific purpose. An analyst who needs to build one Power BI report and nothing else. Schema level permissions let you grant by business domain. The marketing schema to the marketing team. This is where that schema checkbox from earlier quietly earns its place. And at the bottom, the finest layer, row level and column level security on the SQL Analytics endpoint. Row level restricts which rows a user sees. Column level restricts which columns both they enforce at query time. The principle to take away is to reach for the narrowest control that solves the problem. It's tempting to add someone to a workspace role because it takes 4 seconds. And that's how people end up with access to things nobody intended. On the top of all of these sit governance features, sensitivity labels on your data, and integration with Microsoft Purview across your tenant. If you need full cataloging and lineage. The last idea, and it's the one I would most like to stick. Everything we have talked about, clear schemas, consistent naming, descriptive column names, sounds like housekeeping. Nice to have. So the first thing dropped when a deadline arrives. It's not, and the reason has genuinely changed in the last couple of years. Your Lakehouse tables are not only read by people anymore. Fabric IQ data agents query Lakehouse tables through the SQL Analytics endpoint, translating plain language questions into SQL. Copilot in Power BI generates visualizations and answers business questions by reasoning over your model. Semantic models feed natural language exploration across Microsoft 365. Every one of those depends entirely on how well your data is structured and described. Look at the two examples on the right. Same data, both times. The top one, table 2, column 1, column 2, delta table is hard for a person to work with the and effectively impossible for an agent. We're talking about this one. Because there is nothing there to reason with. The bottom one explains itself. Sales order ID, product ID, order date, line total. An agent asked what were sales last month can find its way through that. So the naming discipline that used to be about being a good colleague is now also about whether the intelligent features sitting on your platform can function at all. That's a considerably better argument for doing it properly than any I had 5 years ago. Let's pull the whole thing together. We started with a compromise. Lakes are flexible, but cannot transact. Warehouse transact, but are rigid about what they will accept. Most organizations ended up running both and paying for the seam between them in duplicate data, divergent permissions, and a pipeline that breaks at 3 in the morning. A lakehouse removes that seam by bringing database capabilities to files in a lake. In Fabric, those files live in OneLake with two engines over them, Spark and SQL, and one copy of the data underneath. Inside the Lakehouse, two zones. Files takes anything and enforces nothing, and is where raw data lands. Tables holds data tables, which are Parquet files, plus a transaction log. And that log is what buys you ACID transactions. Schema enforcement, time travel, and efficient updates. 5 ways to get data in. Choose on who owns the thing and how often it runs. And where you can reference instead of copying, use a shortcut one copy, always current permissions intact. Two ways to query. The SQL Analytics endpoint is read-only T-SQL and views, notebooks for Spark, exploration, and anything that writes. Power BI sits on top in the direct lake mode, reading those same data files with no copy and no refill. And the sentence at the bottom is the one to just get out of the room. Every table in a Fabric Lakehouse is a delta table. All of this is on by default. Okay, so that is the Lakehouse, what it is, why it exists, why is inside it, what's inside it, and how data gets in and out. Now you will have notes that today has been mostly about understanding. I have shown you pieces of the product, but I have not asked you to build anything. That changes tomorrow. In our next session, I'm going to demonstrate how to create a lakehouse, hands-on keyboard, from an empty workspace all the way through a table you can query. We will create the workspace and lakehouse from scratch, and I will point out the settings that matter as we go past them, including the schema checkbox I made a fuss about. We will ingest a file and load it into a delta table. We will query it two ways, through the SQL Analytics endpoint and through a notebook. And we will look at the transaction log directly and watch time travel work, which is the moment where delta will stops being an abstraction for people. If you want to follow along tomorrow rather than watch, there is one thing to sort out beforehand. Make sure you have a Fabric workspace with capacity attached, trial, premium, or Fabric. Without capacity, you will get through the creation dialog and then find nothing will run. If you are not sure, check today rather than at 5 past the hour tomorrow. Everything from today, these slides and the notes, goes into the channel after we finish. Thank you for the hour. Let's take questions if there are any. So I'm just going to end today's session. Thank you very much for your attendance. I will meet you tomorrow. Thank you.